Right, good day once more, good people. Today I would like us to proceed, right, and continue with the reaction that is referred to as the Claisen condensation. Right? Now, imagine that you have been given this compound, as your target molecule. As your what? As your target molecule. Now the question comes now, like, how would you design a retrosynthesis followed by a synthesis, right, to generate this target molecule? So what exactly do you do first, right? So what you do here, you look at your functional groups. You look at your what? At your functional groups. For example, if I look at this compound here, I see that there is a C double bond O here. This C is bonded to carbon. This C is bonded to carbon. That's a keto group. That is a keto group. That's a ketone. Right? Now, if I look on this other side, I see a C double bond O here. That C is also bonded to an alkoxy group, an ethoxy group. This is an ester. This is what? An ester. So here you've got an ester on one end. You've got an ester on one end. And then on the other end, you've got a what? You've got a keto, what colloid group. Therefore, this compound that you have here will therefore be referred to as what? As a keto ester, for example. Now, let us number our carbon atoms, right? Now, which one takes precedence? Which one is going to win in terms of these two functional groups? It's an ester, right? Therefore, with respect to the ester, this will be your alpha carbon atom. Then this will be your beta carbon atom. Therefore here, you've got a beta, right, keto. You've got a beta keto what? Ester. So this is what you have here as your target molecule. Now, the question that is asked now, right, employing this Claisen condensation, how did we arrive here? That is the question in actual fact. So what then do you do now, like in terms of retrosynthesis, in terms of your disconnection approach? You go to the alpha beta, what call it bond, and break that bond, right? Then this is the bond that's going to break, or rather, this is the bond that is going to be formed. This is the bond that's going to be formed in the so-called what? Claisen condensation type of what called like action. So your disconnection is going to be here. Let's disconnect this and see what is that we're going to get. In this case now, like if we're going to disconnect at the alpha beta bond, that is with respect to the ester what called like group, this is what we're going to get here. We will end up with pH, this here. This would be double bond here, 1, 2, 1, 2. So it means that now like this here would be, this carbon atom here would be positive, right? Why? Because the other fragment that I'm going to get that side, it would be this here, this, that, there's your OET, 1, 2, 1, 2, then there's your double bond O there, 1, 2, 1, 2, in that case, 1, 2. This would have been what? Negative. This is your pH there now. Right? So it implies that now like the bond that would have that would be broken, it's the alpha beta, what call it? Then now like it means that now like you would have broken this in this fashion, where that fragment will generate a carbanion. This fragment here would generate what? A positive charge on this carbon and carbon on the side, right? Now let's look closer. So what's going to happen here is that now, like here, I have generated a negative charge. There's a single bond here, and there is a source of electrons here. So there's going to be what? There's what we refer to as conjugation. So there is a possibility of the movement of what? Of the electron density, of the electron cloud. Right? This here, these electrons will come here and generate a double bond. As these electrons here are pushed out, right, to generate an oxygen that is negative in charge, right? So we say that now, like, this is resonance stabilized, right? Then we generate this intermediate here. This here, there's your OET, that's right, 1, 2, 1, 2. Here, there's your single bond, O, 1, 2, 1, 2, 1, 2, which is negative. There's your double bond formed there. You generate what we refer to as an ester enolate, if I were to put it that way, right? In this case here, right? Remember, we must, with disconnection, right, we are breaking everything down, right, into simpler components, so to speak. So in this case here, now, like, what is it that we might have had here, right? Before, so it means that here we must have had a group that was a good living group in this case. In this case now, like, if I look at what we have formed here, right, it's an ester, right? So here it's the alkoxy group in this position, like it's your ethoxy group. So your alkoxy here would have been your O12 12 12 minus, that is Et, right? Now let's move further than that. So what could have happened here is we could therefore have started with what? This, that here, this double bond O, 1, 2, 1, 2. This is our pH, and then here we must have had this ester as our starting, material. This must have been my starting what? Starting material. Right? That is derived from this fragment. Then what about that other fragment? Right? The other fragment could have given us this here, this, that, double bond O here, double bond O, 1, 2, 1, 2, there's our OET, 1, 2, 1, 2, there's our pH. Now can you see now, like, we end up with what here now? pH, CH2, pH, here, this was our CH minus. So it means that now, like, they must have, we must have had an abstraction of this proton in this alpha, position here. So this must have been what? CH2 before it became CH minus in this case here. Right? So we end up with these two ester groups or ester molecules in this case. So this is my starting material and that is my starting material. pH CH2, C double bond O, and then C double bond O, and then OET. This also was my starting material. So I ended up with two esters as my what? As my starting materials. So what is the Claisen condensation all about? The Claisen condensation is all about condensing two esters, like so to speak. There's my ester and there's my ester. Then an ester and an ester will give a beta keto ester, right? So this is my retrosynthesis. This is my what? My retrosynthesis. This is my retrosynthesis. This is my retrosynthesis. retrosynthesis. This is my retrosynthesis. So in a nutshell now, like, if I were to look at the synthesis, right? In this case now, like, it means that now, like, in terms of synthesis, I will have 2 times these molecules here, these esters here, pH, CH2, this double bond O, 1, 2, 1, 2, and OET. How many are they? They are 2. It's 2 esters. Condensation of 2 esters. Then, in the presence of what? Because I am forming these, this type of esters, where the alkoxy group like is my OET. Therefore, the base that I'm going to use here will also be what? Na plus O, 1, 2, 1, 2, 1, 2, minus OET. That is sodium ethoxide, right? Then 1, 2, eventually at the end I will have to wash this with an acid in this case. Then I will generate my target molecule. There's my target molecule. That is my target molecule. Would be this in that case, right? And then now, like in the next class now, like I will show you now, like in terms of the mechanism, how does this reaction actually take place, right? Before we go to the next class, I would like to take this opportunity to thank each and every one of you, right, for viewing my videos, right, for sharing my videos, right. I thank you very much for that, and also those students like who have subscribed to my my channel. I thank you very much. That means that all of you guys are supporting me, and I am very much grateful for that. And I urge all those who have not yet subscribed to my channel to please do so, right? Remember, organic chemistry is easy, organic chemistry is beautiful, organic chemistry is fun, right? And every student can do this subject. This subject is not difficult. Students must stop being scared of organic chemistry. Organic chemistry is the easiest subject at university. Okay? I will see you in the next class. Thank you for listening.